I'm Allison Dowda from A Double Dose of Dowda, and let's talk about how to teach converting measurements, specifically to 4th and 5th graders. Let's start with a progression of the standards. So in 3rd grade, students begin by learning about the different units of measurement. They learn how to estimate measurements and how to read measurements on a scale. In 4th grade, students are expected to begin converting measurements. In 4th grade, they are only converting from larger units to smaller units. And then in 5th grade, they are converting all units of measurement within the same system. The best approach to teaching in math is to use the CRA model. So this idea that we start with concrete, where students have hands-on and manipulative approaches to doing the math by touching it. They move to representational, which is where they rely on pictures and drawings and it becomes visual for them. And then they move to abstract, where they are using strictly equations and algorithms. When we are talking about measurement conversions, when we talk about concrete, we are going to have students use liquid containers, having them use balances, scales, and weights, anything like that that they can get their hands on and touch and get a sense of what they are actually doing when they are converting measurements. They need to see it on a scale first where they can touch it. Fraction bars and unifix cubes are also something that you can use to represent some of the tools that you don't have access for them to explore. Representational is the use of graphic organizers and pictures of bars. We're going to talk about that here in a moment and dive into each of these. And then lastly, for abstract, we're going to be focusing on an algorithm that students can use, as well as word problems and how they can solve those. Let's start with making customary conversions concrete for students. I'll begin with blank tables like this for customary length, weight, capacity, and time. Students will help list the measurements from smallest to largest. So it should be a review for them that the smallest unit for customary length would be an inch, then a foot, then a yard, then a mile. Next, I give students rulers and have them focus on just one of these given units at a time. Students typically can already tell you that there are 12 inches in 1 foot. And you give them a chance to put rulers together and they can tell you that in 2 feet are 24 inches. In 3 feet, when you let them put more rulers together, would be 36 inches. 4 feet are 48 inches, and so on. So they get the opportunity to explore and discover this on their own. And I like to have them record these answers in a new table somewhere else. So I'm just writing it here on the same page, but I probably wouldn't include it on the same page for this. The next thing I would ask students to do is to begin noticing some patterns. And so as they're doing that, what I can anticipate is that they will notice, we increase by 1 as we're going down on the left side, 1, 2, 3, 4. On the right side, we're increasing from 12 to 24 to 36 to 48. What we want them to come up with is that what is happening whenever we move from feet to inches, each time that we move this way, we're multiplying by 12. And so 1 times 12 is 12, 2 times 12 is 24, and so on as far as you go. Now, what then I want them to do is I want them to record that once we've established that pattern and that it's true for any time that we are converting from feet to inches. We're going to multiply times 12. Then back here on the original table, we are going to notate that there as well. So in this case, what I like to have them do is I like to have them draw an arrow. When we're moving from a foot to an inch, we multiply times 12. Now, since 4th graders, the standard is only for them to move up this chart, to move from a larger unit to a smaller unit, all they are going to be doing is multiplying. However, for 5th graders, we need to ask them, well, what are we doing then to get from inches to feet? And in these cases, we want them to see that the pattern is we are dividing by 12 when we move that way, just like over here, we want to record that. Whenever we're going from inches to feet, we divide by 12. Then I repeat this process for just whatever tools I physically have available in my classroom. For instance, if you have yardsticks, then next you would have them go through this process and determine how many feet are in 1 yard, 2 yards, 3 yards, and so on. And then they would record in this chart just like they did before. So they would be discovering that to move from yards to feet, they are multiplying by 3. And again, for 5th grade, they would be moving this way, dividing by 3. If you do not have a lot of measurement tools on hand, then one thing you can use for exploration, a creative solution, is to use fraction bars or unifix cubes. Sometimes unifix cubes are also called connecting cubes, and you might have easier access to those to borrow from a lower grade level teacher. So what we do with the fraction bars is we establish that this larger unit is one whole, and the smaller unit is going to be a fraction tile. So for instance, if we're talking about feet and inches, our larger unit, the foot, is going to represent one whole. And since it takes 12 inches to make one whole foot, then we can use twelfths to represent the inches. And so that's what they would be working with in this case, and they can physically count, the twelfths and figure out how many feet there are. With connecting cubes, what you do with those is you can establish that, say, 12 units equals 1 foot. Now, that's not actually going to measure 1 foot if you have a ruler to check it, but it's just representing how many it takes to create one whole. And so 3 cubes, if those were feet, could equal 1 yard. Note that whenever we use the unifix cubes or these fraction bars, they're best just for an introduction, and they are only good for moving across 1 unit of measurement. That's what we're going to start talking about next, is multiple units of measurement. So the next thing that I would have students do with the rulers and yardsticks and whatever tools we have at our disposal, I'm going to ask them to consider how many inches are in a foot and how many feet are in a yard. And I would want them to find for me, using yardsticks or putting together rulers, I want them to discover that there are 36 inches in 1 yard. And that should not be difficult. A lot of them will come in already recognizing that or pick it up very quickly. The challenge is I want to refer them back to this chart, and I want for them to pose them with, okay, mathematically, how can we show 36 with what we have here? What we want them to see is that when we multiply something times 3 and then again times 12, what we're doing is we are multiplying it by 36. So whenever we're using this chart and we need to convert across more than 1 unit, you multiply the numbers together to tell us what we need to multiply by. Now, you can continue doing tables just like this with measuring cups for capacity, clocks for time, balances and scales for weight. Now, of course, for some of these, you just have to tell students, for instance, how many feet are in a mile or how many pounds are in a ton, because you likely aren't going to have resources for them to discover that on their own. One quick tip that I would like to share for capacity is what I call the gallons chart. Honestly, I myself never remembered measurements for capacity until I started using this chart for teaching. So what you can see here, this is an anchor chart that I use in my classroom, and we call it the gallon chart or the big G because the gallon is represented with the big G. There are 4 quarts, 4 Qs in a gallon. There are 2 pints in a quart, and there are 2 cups in a pint. So this is an incredibly visual way, as we start talking about representation in a moment. This is an incredibly visual way for students to remember capacity because some of those numbers can be a little bit funny. And like I said, for me, whenever I have to solve something for capacity, I think of this in my own life. If I'm, cooking and need conversions, I picture this chart in my head and it helps me solve problems too. So this is the anchor chart that I like to use with my students, and I will link this in the description for this video in case that's something that you would be interested in getting for interactive notebooks, as a full page printout, or even as a poster. I have that available. Now, by the end of going through all of these measurements and completing these tables, students are going to have a table that looks something like this. And this is a cleaned up version of everything that we just talked about here, like the length stuff is all listed here as well. Of course, fourth graders do not need the division piece on these tables, the right sides. Fifth graders do. But students can keep their originals, or I like to take them through having their originals, but sometimes that gets a little messy. Just with spacing and things, they don't have it set up in a way that it's an easy reference for them later. So I do like to go ahead and give them a copy of this to put in their notebooks. I also print this as a poster, nice and large, and hang it on the wall so that they always have a tool for reference. This anchor chart is essential as we move through to the representational phase of the CRA model. With a little practice, most students can easily use this as a reference to complete problems and tables. For instance, if given a question like this about converting pounds to ounces or ounces to pounds, they should be able to use this table and see what they're going to be multiplying or dividing by if they're in fifth grade, multiplying and dividing. But they're going to know how to use the table to complete charts like this, so with multiplication. One piece for differentiation that I do want to point out is sometimes for some students, and this doesn't work for all units of measurement, but there are some that it can, sometimes it's best for students to be able to draw out pictures. Now, what that can look like is this. Let's say that we are asking students to find how many feet are in 3 yards. And I'm selecting this one because it's smaller, it's easier to draw, and this is something that you would do smaller problems like this with students as well, just to help them visualize. But let's say that they have 3 yards. So this is, again, imagine this is kind of like the fraction bars that I referenced earlier. Let's say that this is 1 yard, 1 yard, 1 yard. And I need to know how many feet are in 3 yards. So in this case, for some students, it really helps if we can get visual with them. So I've got 3 feet in 1 yard. I've got 3 feet in the second yard, and I have 3 feet in the third yard, and then they can count those 1, 2, 3, 4, 5, 6, 7, 8, 9, and that helps them to visually see that 9 feet equal 3 yards. So again, differentiation, this is a great way to represent the problems if they're not quite ready for the conversion charts on their own. For those visual students and the students who just really benefit from being able to see things, I do like to, in the level 1 of my task cards, for instance, these are some customary measurement task cards that I have. My level 1 always has visuals in all of my task cards as best I can create those. And so for this one, you can see I have my gallons chart on this one for students to figure out how many pints are in 2 gallons. And in this one, how many inches are in 3 feet. It's here so they can see this and they can see it represented visually. All right, lastly, let's talk about how students can solve customary conversion problems abstractly. And we're going to do that by setting them up to create equivalent fractions. For instance, if we want to say 5 pints equals how many cups? Here's what we can do. To set it up as an equivalent fraction, we say that we know that 2 cups are in 1 pint, and we want to know how many cups are in 5 pints. We have to make sure that students understand that we keep, in this case, we keep the cups both in the numerator and the pints both in the denominator. if they're solving problems like this, it doesn't matter which they choose for the numerator, which they choose for the denominator. However, the units across the numerators have to be the same. The units across the denominators have to be the same. So if they are really good at equivalent fractions, then this will be a great model for them to follow. Because what we need to do is we need to figure out, okay, if this is going to be an equivalent fraction, how did I get from 1 to 5? I multiplied by 5. How do I get from 2 to whatever is here? I'm going to multiply by 5. So 2 times 5 is 10. And again, you can have them use their little chart here. And if they have 5 pints, 1, 2, 3, 4, 5 pints, that would be 2, 4, 6, 8, 10 cups. So this equivalent fraction model is abstract and it doesn't rely on the representations of the charts, but it's something that especially for advanced students who want to get through problems quickly and save time, this is a great option for them. Let's talk quickly about metric conversions, because so far we have just talked about customary conversions. You can have students go through a similar process to before, where we were using measurement tools and figuring out the conversions so they could actually see those things. But instead of using tables like this that we created for the customary units, I like to use a model that looks a little bit different. Let me move some of this out of the way. So this is the model that I like to use for metric conversions. To remember the prefixes for metric conversions, I teach students a silly phrase, and I know lots of people have their own silly phrases that they do. But for me, I teach students kangaroos have dandruff, but don't care much. Kangaroos have dandruff, but don't care much. With metric, the same prefixes, of course, work for meters, liters, and grams. So B, I always underline because that is our base unit. That is meters, liters, and grams. And I like to have them, at least in the beginning, write those things out. Then I will remind students, this is a conversation that we would have already had, but if this is their first time seeing it, then it's a good time to present it to them. So let's say that I have 10. The number 10 itself, if I had to place a decimal here and not change the value, students should know that it can go here and not change the value. In addition to placing the decimal and not changing the value, students need to know that I can put as many zeros after a decimal as I would like and not change the value. In addition, I can put as many zeros in front of my whole number, and it will not change the value either. Now, just like before, sometimes I will have students on their charts, you can see it here, but just like before, I will have students, we need to know that every time we move to the right, we are multiplying values by 10. And I won't go through and mark all of these, but going this direction, we multiply by 10, going this direction, we divide by 10. And after we have students try some of these out, then I teach them the shortcut, the decimals shortcut. So what we do for this one is, let's say that I have 10 meters, and I want to know how many centimeters there are. I tell students what we need to do is we need to have our number 10, which I already have written here, and we need to see how many jumps and in what direction do we move on our chart up here from meters to centimeters. Remember, meters is our base unit, so that would be like a decimal being here. How many spaces do I move to centimeters? I move 1, 2 spaces. So my new decimal point will be here. So for the number 10, where my decimal point is placed, I will make 2 jumps to the right. And so that new number is 1, 0, 0, 0. So 1,000 centimeters. I probably wouldn't start with just the number 10 for them because that extra 0 can be a little tricky. I would probably start with just ones or single digit numbers for students. But once they learn this trick, the problem that they tend to have, they especially get confused whenever we move the decimal to the left, and if their answer is something less than 1 whole. So for instance, on this one, maybe if there were 10 meters equals how many kilometers or kilometers? Well, in this case, let me get a different color pen. In this case, I will move the decimal from the base units, and it needs to go here. That is one strategy. Also, I will often have them place their decimal before they start their jumps, because otherwise they'll go too far. They'll get confused and they'll want to put the decimal in front of the K instead of after. So place the decimal, and then we count our jumps. 1, 2, 3. So in this case, we're going to move this decimal 3 spaces to the left. 1, 2, 3. So my answer on this is, I didn't leave myself enough space here, so I'm going to write it down here, is 0.01. Now, that's a good opportunity to have a conversation with students about, I could make it 1/100th. I could make it 10 thousandths. Remember, zeros after the decimal can go on forever and not change the value at all. So having those conversations with them, and in this case, I do just like students to be in the habit of, if there's a decimal, I want to see a 0 in front of the decimal point. Again, on my task cards, for my easiest level of task cards, I like to give them their little hints and cues. So in this case, when they're moving, I do tell them what we're multiplying by, or you can remind them about the decimals. I do like to keep it here at the top for them. So then for the second level, then they've got, they've got some decimals thrown in. They don't have the arrows there. But really, the decimal moving is where I want students to land, just because that is the most time-saving and efficient way to solve metric conversions. So those are the ways that I take students through the CRA model for converting measurements. Milestones. Now for 4th and 5th grade, these are pretty much going to look the same. These are kind of the big points that we want to make sure students can do whenever they are converting measurements. First is they need to be able to relate units to common items that they are familiar with. Again, if they don't have a sense of the items and what size things are, they're going to struggle with doing the measurements and the conversions. Next, they need to be able to convert measurements. Again, 4th grade only needs to be able to move from larger units to smaller units. They need to be able to record measurements on a table. So given a table, they need to be able to fill it in correctly. And then lastly, especially in 5th grade, we need them to be able to do multi-step word problems. So more than one operation that they are using. If you find students are having trouble with any of the things that we have mentioned, some interventions are that they may just need to review relating unit sizes to common items that they are used to seeing and using every day. Converting units is what most students are going to struggle with. So in those cases, it's really helpful for them to have little reminders, little tools that they can use like this that I shared, so that they can reference what they need to multiply or divide by to get to the next unit. Keeping those handy is going to be a great intervention for students who are struggling, and making sure that they know how to read that chart and use it well. One differentiation for them might be, instead of giving them this whole thing, maybe they just focus on one particular part of it. And maybe you just have that part printed and that's all. And some students may never move to the algorithm piece that we talked about in the video. Some students may just live in the representational, where they do have to rely on the chart quite often. And for most students, they're going to be able to answer grade level questions by doing that. As enrichment, so if you have students who are really doing well and they need a little bit of a challenge, It's not uncommon in converting measurements for us to use decimals, especially when we are using the metric system, but perhaps you can throw in for them some fractions. And so they will have to convert fractions to decimals, and then that's what they can use whenever they are converting their measurements. So that is a great area for them to practice using fractions in that as a challenge for sure. I have put together a couple of different activity packs. Whether you teach 4th grade or 5th grade, I have a 4th grade pack that only includes moving from larger units to smaller units for converting, or I have 5th grade where they go larger to smaller units and smaller to larger units. Each of these has the same content, just on those different levels, whether it's all across all units or larger to smaller only. So for each of these, there are 5 worksheet mazes. And what is helpful about this is for each of these, there's one maze about customary length. There's one maze about customary weight. There's one maze about customary capacity. There's one maze about time. And then there is one maze that focuses on metric. So 5 mazes in each bundle. Also, there is an anchor chart for each bundle. The customary conversions and metric conversions chart that I shared in the video already, that is included in this bundle. For each bundle, there are 2 tic-tac-toe games. So one is metric and one is customary units, and where students have to convert. And then there are 2 task cards in each of these units. Again, one customary, one metric, because I like having them do these in isolation. Even though they're both measurement conversions, I don't know, they just feel very different doing customary and doing metric. So to make sure that they have enough practice with those, that's what we have for that. And then lastly, each bundle has 2 bingos in it. One is going to be customary and one is going to be metric. So again, if you are interested, that bundle is put together for you, and you can find it in our store on Teachers Pay Teachers. It is linked in the description below. Lastly, I have a free handout for you. Everything that we talked about today, as far as the progression of the standards goes, as far as the different strategies and techniques that you can use for the CRA model, are listed, the milestones, as well as ideas about differentiation and where to focus your instruction whenever you are intervening or enriching. So I like to have those printed and put with my lesson plan books. I just find that a helpful practice. I hope that you loved this video and that it was able to help you inform your instruction for your students. Please let us know what you think. We always love to hear your feedback. As always, thanks for watching, and we would love for you to subscribe to our channel.